Hello, my name's Eric. Today I'm going to show you how to find the Fourier coefficient of the function given, which is f of x is equal to x on the interval negative pi to pi. Given the general formula, f of x is somewhat equal to a naught plus the summation a sub n cosine nx plus b sub n sine of nx. We start by finding a naught. Given the formula, a naught is equal to 1 over 2L on the interval negative L to L f of x dx. We start by saying 1 over 2 pi times the integral negative pi to pi x dx. And we know that is equal to x squared over 4 pi. Multiplying the 2 times the 2 pi. Between negative pi and pi, just considering the numerator, we can see that negative pi minus a negative pi, either one squared, will give you, when this squared, the negative sign goes away, so you just end up having pi squared minus pi squared is equal to 0. So a naught is equal to 0 in this case. We'll put that off to the side over here. And we'll work the second part of this. A sub n is what we need to find next, given the formula 1 over L between the interval negative L to L f of x cosine nx dx. Okay, so using trig tables, we can say that this goes. Well, we won't use it yet. We'll plug in the values first. 1 over pi from negative pi to pi. X cosine nx dx. Okay, there's a lengthy integral there, but it's directly out of a table, and it says 1 over pi times cosine nx over n squared plus sine nx times x over n between negative pi and pi. Now, it's no surprise that when you plug a pi into sine, that goes directly to 0. Alright, so we can just say this first one goes to 0. The second one, not so intuitive, so we'll work it out. So cosine of n pi minus a cosine a negative n pi, where cosine pi is 1 minus cosine of negative pi is also 1, we get a 0. So a sub n is equal to 0 as well. So we'll write that over here as well. A sub n is equal to 0. I need a little bit more room. Now, b sub n is equal to, that's what we need to find next right here. B sub n is equal to 1 over L times the integral negative L to L f of x sine nx dx. When we plug our values in for this, we get 1 over pi times the integral negative pi to pi x sine nx dx. And when we use a trig table, which is makes this a lot easier. We get sine nx over n squared minus x cosine nx all over n times 1 over pi between negative pi and pi. Again, back to what we said earlier, when we plug any pi into sine, we'll always get 0. So we'll just mark that out as being 0. We'll work out the cosine again. So x cosine nx, keep in mind the negative sign on the outside. So we have a x would be pi cosine n pi minus over n minus negative pi cosine n negative n pi all over n. Okay? Now, a negative pi minus a negative pi turns this into pi cosine n pi plus pi cosine n negative pi. And we can easily say that cosine n pi, where n is equal to any number, 0, comma, plus or negative 1, comma, plus or negative 2, comma, dot, 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 is equal to negative 1 raised to the n power by a series. So, given that, we'll equate those two. And we'll say 2 pi, cancel, or factor out the pi, times negative 1 raised to the n all over n with a negative sign on the outside, which is equal to saying, factoring out the negative sign, pi, or 2 pi times negative 1 times negative 1 raised to the n power all over n. Well, you have two negative 1s, so you can just add 1 to the n power, which would make it 2 pi negative 1 n plus 1 all over n. So our b value actually has, b sub n actually has a value to it. So when we rewrite this, we'll write it over here to the side, b sub n is equal to 2 pi negative 1 raised to the n plus 1 all over n. We'll rewrite this with its appropriate coefficients. Which makes it f of x somewhat equal to 0 plus summation negative, or 1 to infinity of 0 plus our b sub n, 2 pi negative 1 raised to the n plus 1 all over n sine nx. And that is our final answer. We found a coefficient, b sub n. Thank you very much, and let me know if you have any questions.